Righteous. Is that good? Is that good? Oh man. Good enough. I think it's good enough. What is happening from the 403 to the HAZ? Mr. Nelson here. Hey. So, this is going to be nice. I've been doing some Pre-Cal 12 videos on stuff I have not even taught to students before. So, trying to get up here and create a lesson has been a lot of work. So I'm really excited to talk to my Pre-Cal 11s today to do something that's just more straight algebra, which I really like. And that's basically capping off what we've been doing with rational expressions, but now we're solving for x. And to solve for x, essentially what we're doing is we're just going to use our lowest common denominator strategy that we used when we were adding and subtracting rational expressions. And we're going to use that LCD just to basically get rid of denominators, and then just so we're dealing with, I guess, just numerators, expressions that don't have a denominator, which are easy to solve. So instead of talking about it, why don't we just do it? Do it. So, now this is not a rational expression, but it's a good starting point for learning how to deal with rational expression equations. Or rational equations, I guess we could call them. I don't know. The lingo is less important than the math. Okay, I'm going to make sure I'm still filming because I have just been getting my butt handed to me. So, how do we approach this? Well, basically, what we are trying to do always is get rid of denominators. Denominators suck. They make it hard to solve stuff. So how would we get rid of the denominator here? Well, we just have to ask ourselves, what is the lowest common denominator? And if you said 10, you would be wrong. No. If you said 12, that's great. 12 is our lowest common denominator. So you know what we're going to do? We're just going to multiply everything, both sides of the equation, we're going to multiply by 12. Which means I'm going to multiply everything on this side by 12, and I'm going to multiply everything on this side by 12. And what does that mean in practice? Well, it means that this 12 is going to multiply with this bad boy, and then with this binomial, and on this side, 5 is going to multiply with 12, and then x with 12. So when we do that, this is what we'll get. 12 times x minus 1 over 3 minus 12 2x minus 5 over 4 is equal to 5 times 12 over 12 plus 12 times x, 12x over 6. And now I can just simplify and get rid of all the denominators. So 12 divided by 3 is 4. That's going to get rid of that denominator. Minus 12 divided by 4 is 3. Is equal to 12 and 12 cancel here is equal to 5 plus 12 divided by 6 is 2. Okay. This is looking a lot more manageable. So how are we going to solve for x? Well, we're going to have to collect all of our x's. In order to collect all of our x's, we're going to have to expand out these multiplications here. So again, now this 4 is going to visit each component of the binomial here. So we get 4x minus 4 minus 3 times 2 is 6x minus 6x minus 3 times minus 5 plus 15 is equal to 5 plus 2x. I'm going to collect all my x's and all my numbers on this side. So 4 minus 6 is negative 2x. Minus 4 plus 15 is plus 11. Is equal to 5 plus 2x. Now I'm going to move I'm just going to move all my x's to one side. I'm going to choose to move them to the positive side here. So I'm going to add 2x on each side, and then I'm going to subtract this 5 over here. So 11 minus 5 is 6, is equal to 4x divided by 4. X is equal to 6/4 or 3/2, because 6/4 is the same as 3/2. 6/4 dividing each side by 2 gives me 3/2. That's my answer, okay? Now this was not actually a rational expression because I didn't have any variables in my denominators, but this was a good starting point to just see, we're just going to basically scale up this strategy to other problems. So I'm just going to do like 3 problems here. I think it's going to be enough to get you going. You just have to do what we got to do. So my markers. Me markers, okay. Let's just go for it. Okay. Let's go for it. W minus 3. You know what? Okay, because I want to do one that's an actual rational expression. So here we go. Okay, you know what? I'm just, sorry guys. I'm trying to find the next most logical problem to do with you guys that will make sense. And you know what? I just found it. So let's do it. Okay. We've got 4x. Here we go. Now we're dealing with rational expressions too. X squared minus 9 minus 5 over x plus 3 is equal to 2. Okay. So again, the strategy is we want to get rid of the denominator. And how do we do that? Well, we find the lowest common denominator. But in order to do that, so here this is good. This is as low as I'm going to get here. This is a trinomial but it's a perfect square trinomial. So it's basically, I could rewrite that as x squared plus 0x minus 9. And so then what are 2 numbers that multiply to negative 9, which is a perfect square, and add to 0? And it would be plus 3 and minus 3. And so that's how we would factor this guy. So let's rewrite it now in its factored form in a nice, beautiful ocean blue color. Oh, my goodness. My absolute goodness. Okay. Minus 5 over x plus 3 is equal to 2. So what is my lowest common denominator here? Well, it's going to be this, because x plus 3 is a component of this. But x plus 3 would need an x minus 3 in order to become this. So x plus 3 times x minus 3 is my lowest common denominator. So in the last situation, I'm going to multiply both sides by x plus 3. So let's do that. Both sides I'm going to multiply by, by the lowest common denominator, which is x plus 3, x minus 3. I'm going to do that here too. X plus 3, x minus 3. So when this happens, this is going to multiply with the 4x and with the 5 there. So when we rewrite this, it becomes 4x times x plus 3 times x minus 3 over x plus 3, x minus 3, minus 5 over x plus 3 is equal to 2 times x plus 3, x minus 3. And I'm actually not going to solve, well, we'll see. Actually, we'll see what happens. So when I write it out this way, now I can see that, okay, this is nice. This is going to cancel here. Oh, I forgot to multiply the 5 by the x plus 3, x minus 3, and when I do that, I notice that x plus 3 will cancel here, and I'm left with that. So let's write out the whole thing now. I'm going to have 4x minus 5x minus 3 is equal to 2x plus 3 minus 3, I know is x squared minus 9 times x squared minus 9. I'm just expanding this because I'm going to have to eventually anyways. And then I get here 4x minus 5x plus 15 is equal to 2x squared minus 18. And in order to solve for x on this guy, I'm going to have to move, because I'm noticing right now I've got an x squared term, I've got an x term, and I've got a number. It's looking like it's a trinomial. So I'm going to try and get everything to one side and make it equal to 0. So I'm going to bring all this side over to this side. And when I do that, I get 2x squared. 4x minus 5x is negative x. So when I move it over, it's going to be plus x. And then negative 18 minus 15 is negative 33. Excuse me. And that's equal to 0. And if I wanted to solve for x here, I would have to use decomposition as my factoring method. Where it's basically, and I'm not going to teach decomposition right now. I've got so many videos to get through. You can look for decomposition and learn it there. Fine, I'll do it. Fine. Okay, decomposition. I'm going to multiply these two numbers. Now I'm looking for two numbers that multiply to negative 66 and add to positive 1. 66, 6 times 11, 66. This might not be solvable without the quadratic equation, which is why in the textbook they told us not to solve it. They just said to get rid of the denominator. 63, 11 times 6. Yeah, no, I don't think this is going to happen. 33 times 2. No, I don't think this is possible. And I'm sorry if it is and I'm missing something. So we would have to use a quadratic equation to solve for x here. And I'm not going to do that right now because I want to focus on actually solving the problem or the task at hand. Okay. So let's do another one now. Okay. Let's say I had 3 minus y over 3y plus 1 over 4
Ms. Flynn, can you solve 3100, please, Ms. Flynn?
Now what would my lowest common denominator on this guy be? Well, from a number perspective, it's 12, but then I also have y's. So it's going to be 12y. 12y is my lowest common denominator here. I could have used 24y. 12y is my lowest, so I'm going to use that one. So I'm going to multiply out both sides by 12y. Multiply both sides by 12y. And then the 12y is going to visit this guy, and then this guy. So when I do that, I get 12y times 3 minus y over 3y plus 12y over 4 is equal to 12y over 2y. Now I have to just get rid of the denominators by simplifying. What's 12y divided by 3y? Well, 12 divided by 3 is 4. Y divided by y is 0. And I use that because I know when I'm dividing variables, y squared over y is the same as y 2 minus 1. The top exponent minus the bottom exponent. 1 minus 1 makes y to the 0 or 1. So this becomes 4, 3 minus y, plus 12 divided by 4 is 3. The y stays there. 12 divided by 2 is 6. Y divided by y is 1. So it is equal to 6. And when I expand all of this, because I'm going to try and collect all my y's, I get 12 minus 4y plus 3y is equal to 6. And I have 12 minus y is equal to 6. I'm going to move the y over there, and I get y. Now I'm going to move the 6 over there, is equal to 6. I'm going to add y on both sides, and subtract 6 from both sides. And in doing so, I'm just isolating for y. I get y is equal to 6. Great. Okay, let's do, I'm going to do one more. I think one more is good enough, guys. Because we've done all this with the addition and subtraction. It's really nothing outrageous, but let me do a good one for us here. Okay, I'm going to do this one. This was what I was going to do before, but I thought I was getting too fancy too fast. Okay, so I'm trying to solve for d here. And again, I've got fractions. I don't want denominators. So the first thing I need to do is figure out what my lowest common denominator is. But in order to do that, I need to factor this. This is not going to help me. So let's factor that. And I mean, you can tell. Okay, what are two numbers that multiply to make -4 and then add to +3? Well, 2 and 2 makes 4, and then 4 and 1 makes 4. A +4 and a -1 will give that. So d plus 4, d minus 1. 4 times -1 is -4, and then I'm going to have 4d and -1d to make 3d. Okay, so that's how I factor that. So let's rewrite it now. And my lowest common denominator is going to be this too. So I'm going to multiply everything by that. All of both sides I'm going to multiply by my lowest common denominator. Okay, so this d is going to multiply there, and then this 2 minus d is going to multiply there. I should put I'll put the arrows in the opposite direction so as not to confuse you. So when I do that, I'm going to multiply, I get d times d plus 4, d minus 1, over d plus 4 is equal to 2 minus d times d plus 4 times d minus 1 over d plus 4 d minus 1 plus d plus 4 d minus 1 over d minus 1. Okay. Cancel, cancel. Cancel, 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 cancel. Cancel, cancel. I'm left with d times d minus 1 is equal to 2 minus d plus d plus 4. And I'm going to expand it. D times d is d squared minus d is equal to 2 minus d plus 4. The d's here cancel with each other, and I'm left with d squared minus d is equal to 6. And I can see a squared term, a d, and a number. So I can see this is looking like a trinomial. So I'm going to move everything over to one side on that, and in doing so I get d squared minus d minus 6 is equal to 0, which when I factor, this is one of the ones that we see a lot, is d minus 3, d plus 2. Two numbers that multiply to make negative 6 are negative 3 and positive 2, and negative 3d plus 2d gives me negative d. Therefore, my answer here is that d equals 3 and negative 2. Great. Hopefully I'm still filming. Holy crap, just so much luck today. Okay, that's how you solve rational expressions. Not so bad. And sometimes they ask you for the non-permissible values, and you can just take them here. So d can't equal negative 4, because that'll make this 0. And d can't equal 1, because that'll make this 0. So I could have added that, where d cannot equal negative 4 or 1. Okay, go forth and prosper, my babies.